The following is a production of the Metro Applied Research Club and the Department of Computer Information Systems at the Metropolitan State University of Denver, with special thanks to our corporate sponsor, Nebraska Aluminum Castings, quality, custom aluminum die casting in Hastings, Nebraska. This is part 2 of the lecture Association Rules. If you have not watched part 1, please stop the video and watch part 1 now. Let's do another example and see how we come out. Let's consider marital status and the amount a person has in their savings account. Here we examine two antecedent factors, marital status and savings account amount. Again, the first thing I want to do is simply count the number of occurrences of the antecedent. For example, in cell P15, I use the COUNTIF function to count the number of instances where an individual is single and has high savings. Then, in cell P16, I count the number of times someone is single and has high savings and the person has a high credit standing. In this case, the antecedent is single and savings high. The consequent is good. Now, we have an interesting result. Note that the confidence of this rule is relatively high. If a person is single and has high savings, they should have a relatively high credit standing. However, look at the support for this rule, only 1.6%. The upshot is that when this rule does apply, it is a relatively good predictor of credit standing. However, this rule does not apply very often, in fact, less than 2% of the time. The fact that the rule has low support is not extremely meaningful. In a data set of 1 million transactions, 2% would represent 20,000 transactions, a large number by almost any standard. What is more important is the actual number of times the rule is examined. There are only 9 instances of the antecedents, and 7 of the instances of the rule are true. In the case where we are examining such low numbers, we must ask if the results we have determined can be safely assumed to apply beyond our data set. For example, if we add just 3 more instances of single people having high savings and they all turn out to be bad credit, the confidence of this rule would change from 7 out of 9, or 77.7%, to 7 out of 12, or 58.3%. We also notice how close the ratio 7 out of 9 is to 5 out of 9. That is, if we were to change just 2 of those instances to bad, we'd have about a 50-50 chance. What this tells us is that this number, as we see it here, is pretty accurate, but it's not exactly something we can take to the bank right now. Another limitation of any data set is overlearning. In overlearning, our tactic is very good at finding very effective rules within the data set, but they are not effective beyond the data set. The idea of an algorithm or tactic overlearning the training data is common across any inductive algorithm. Finally, let's note one more time that the rules for marital status are both mutually exclusive and collectively exhaustive. Again, mutually exclusive means that an individual can be in one and only one category, either married, single, or divorced. And collectively exhaustive means that all those categories represent all the possible outcomes. Obviously, this may not really include all the possible outcomes. For example, you could be separated. But for the intent of the problem, we can see if the rules are collectively exhaustive by looking at the yellow cells. If we add up all of these options across all the rules, the probability of their occurrence should be 1. And that's exactly what we see in cell Q13. Also note that the green cells add up to 1, meaning that if you are single, then you fall into the category of single with good credit or single with bad credit. If you are single, you must fall into one of these categories, and you cannot fall into both. The same is true of the blue cells. They should add up to 1, as should the orange cells. So let's wrap up. In this lecture, We learned what association rules are and what they can be used for. We saw some examples, and we learned some very basic ratios for assessing the information value of a given association rule. I hope you enjoyed the lecture, and most especially, I hope you learned something. Have a good day.